That brings us to our next speaker, Peter Bertone from Dartmouth. And the title of his talk is Post-Radiation Renovation, Rebuilding Stronger Homes with Better Bones. Peter?
Awesome. Thank you for the introduction. So imagine you wake up one morning and you go to the bathroom and you look up in the corner of your bathroom and then it's just the corner is missing and it's been eaten away by mold and there's some mold spores kind of, eating away that corner of the bathroom. And typically the way you treat that, right, is you spray it with something. Well, you kind of cut away the mold that's there and you want to rebuild it and treat it so no mold spores grow back and sort of the problem persists. And you want to rebuild it to make sure the framework is good and the insulation is there and the plaster is there. Well, that's essentially kind of what happens in the bone from a primary or secondary bone cancer, right? That bone cancer comes in, you need to resect it, and then you treat it, and you typically treat it with radiation. So the goal of my research is to investigate and build a material that can work good in the work well and effectively in the context of regenerating and rebuilding bone that is undergoing treatment following tumor resection. So first thing, we want to build a foundation with the material. So right now I'm investigating cryogels. And what I did is I irradiated these cryogel samples with clinically relevant doses of radiation and then tested whether or not they were still effective at conducting osteoblast-like cells on their surface and throughout their system. And what I found was that our cryogels are still effective at regenerating tissue, bone-like tissue, after up to 21 days following radiation. Secondly, I want to create a material and incorporate things into our material that make it stiffer and stronger to be able effective in terms of structural, give it structural support in the context of creating stronger better building blocks essentially. So what I've done is I've incorporated 3D printed hydroxyapatite cages essentially with our cryogel material to increase, and what we found is it significantly increases both its finally, I've been conducting a murine model, a critical segmental defect model in a mouse, where I've induced a critical defect, and then I'll fill that space with a cryogel, then leave it as a control or irradiate it with these scaled clinically relevant doses of radiation to investigate what that regeneration looks like over 4 and 8 week time points. And what we found as compared to the control as well as the defect that is left empty, following those doses of radiation, we're seeing clear bridging across that section of the defect, across that length of the defect, regardless of the radiation fractionated dosing regime, as well as compared to a control. And those are images there with the micro CT and the MRI qualitative images so far. So exciting stuff, and trying to essentially make the next building block to build back better, stronger bones following radiation therapy. So thank you.